Okay, so let's start doing our first stoichiometric unit conversions between moles and grams. Before we do that, we need to establish some definitions. So you will recall that Avogadro's number represents the number of atoms in the gram atomic mass of an element. So we said this in the previous lecture, that there is 1 mole, or 6.022 times 10 to the 23rd carbon atoms in 12.01 grams of carbon. And this 12.01 grams of carbon is just carbon's atomic mass, its top number on the periodic table. We could say that for any element on the periodic table. So there are going to be Avogadro's number of copper atoms in 63.55 grams of copper. That is simply copper's atomic mass from the periodic table. There are going to be Avogadro's number of hydrogen atoms in 1.01 grams of hydrogen. So we can say that for any atom on the periodic table, but the same concept also applies to molecular mass. So you recall that we learned how to figure out the molecular mass of a compound. Let's take water, and this is just to review. Water has 2 hydrogens and 1 oxygen, and each hydrogen has an atomic mass of 1.01. So there are 2 of them. Each oxygen has an atomic mass of 16. So I have 2.02 plus 16, giving me an atomic mass of 18.02 for water. So this is molecular mass rather, not atomic anymore because we're talking about the water molecule. So this is how we calculate the molecular mass of water. And you can do this for any chemical formula. So what we just said about atoms also applies to molecular mass. What this means is that 18.02 grams of water is going to contain Avogadro's number of molecules of water. 6.022 times 10 to the 23rd water molecules. So we can say this for any molecular mass of any compound. A compound's molecular mass is going to contain Avogadro's number, or 1 mole of that compound. So we had said before that 1 mole of anything is equal to Avogadro's number of that thing, 6.02 times 10 to the 23rd of whatever that thing is. And it could be anything, atoms, molecules, people, pencils, doesn't matter. And also, we said that 1 mole of carbon atoms is going to be equal to 6.022, Avogadro's number, times 10 to the 23 carbon atoms. And that's also going to be equal to the number of atoms in 12.01 grams of carbon. For molecules, we can say the same thing. 1 mole of water molecules is going to be equal to Avogadro's number of water molecules, 6.022 times 10 to the 23rd water molecules. And that is also going to be equal to the amount of molecules in 18.02 grams of water. So now let's get to the topic of converting between moles and grams, because this leads us directly to the ability to convert between grams and moles. So doing this, you want to use dimensional analysis, just like we did with unit conversions in general. Dimensional analysis, also known as the unit factor method, where you cross multiply and cancel units. That's going to be the best way to do these sorts of mole-gram conversions. So, given everything we just said, how many moles of water are there in 180 grams of water? So let's say I weigh out 180 grams of water on the balance. Can I figure out how many moles there are? Well, all I need to do is get this conversion factor, that there is 1 mole of water molecules in 18.02 grams of water. That is the conversion factor that I need. 1 mole of H2O is going to be in 18.02 grams of water. That is just simply the molecular mass. So now I can take the 180 grams and cross multiply it. 180 grams of water, I'm going to multiply it by this conversion factor, putting the moles on top. There's 1 mole of water in 18.02 grams of water. That is going to give me approximately 10 moles of water. So there are going to be 10 moles of water in 180 grams of water. We just did our first mole-gram conversion. Now let's go in the opposite direction with another example. How many grams of nitrogen are in 10 moles of nitrogen? So there we need to figure out what the molecular weight is for nitrogen. Each nitrogen is approximately 14 atomic mass units. So that means for 2 of them, I'm going to have 28. Okay, that's just using the atomic mass of nitrogen, which is 14 for each of them. So now I have my conversion factor, and I can say that if I have 10 moles of nitrogen, then multiplying that by 28 grams per mole gives me 280 grams of nitrogen. So that is the number of grams of nitrogen that are going to be in 10 moles.